So yeah, we have to fill a random function according to us. Ah, okay. We can do this, right? Yeah. This is 6. This is 0.009. This is 1. For fx negative, and the root of fx does not exist. This is not point 4. 0.4 into 0.4. Yeah, point 0.4 into 0.4 is 0.5. This is
Okay, I think for question 2,
mm-hmm.
you just take the y value and you square root it, unless it's a negative. If the y value is a negative, then it's not possible.
Yeah.
For question 2.
Yeah. For each. Okay, so these are these are the points of fx.
Yeah.
Okay, for each point on the graph, so that states the coordinates. For this, it will exist. For this, it will not exist. Exist, not exist.
So for B it exists because y is not negative, x is
Okay,
negative.
sorry. This- I was thinking opposite. Sorry. Not exist. Exist. M. It will depend. We have to say like if n is positive, it exists. I thought this question and this question. Okay, no.
And then the next question is 5, C, and D.
5 C and D. Identify, determine domains and ranges of the function in the sphere graphically and algebraically. Okay.
You know what? I'll tell you what we studied
Yeah.
first. So basically what we did was we took the square root of different functions. Actually, no, a linear function.
Mhm.
Okay.
Mhm.
And also a quadratic. So we did both.
Mhm.
We square rooted the y
Mhm.
and we tried to find invariant points because
Mhm.
at one, um, they're always gonna intersect when
Mhm.
y is 1. Oh,
Mhm.
sorry, when x is 1.
Now y is 1.
Yeah. Okay.
Mm.
When y is 1 and when y is 0, I think.
Yeah. Y is 0, they will intersect. Yeah.
Yeah. And then we found table of values
Mm-hmm.
um for it, the domain and range,
Mm-hmm.
the x-intercepts, y-intercepts, and the maximum value and the minimum value.
Okay. Awesome. So for this also, the main thing about domain and range in square root of a function is for fx less than 0, your under root of f of x does not exist. This is one thing. And when f of x is between 0 and 1 or less than 1, your under root of fx will be greater than f of x. This is because, like, if you do under root of 0.09x, 0.09, just a number. This is between 0 and 1. Its result will be 0.3. So you can see that, and this is under root of fx now. This is under root of fx, and fx is 0.09. Under root of fx is greater than, this is greater than the original function. And when fx is greater than equal to 1, f of under root of fx is less than equal to fx. Yeah.
Okay.
These are the pillars of solving this question. So C part. So we need to check three things: where it is, the main function is negative, where it is between 0 and 1 and greater than that, your y. So this graph is minus of y equals to minus x plus 9. So it will go like this. At 0 it is 9, slope is negative and equal to 1. At 9 it will be 0, x equals to 9, it will be 0. And like this. This is your f of x. So it is for x less than equal to 9, your f of x is greater than equal to 0. So the domain of under root of fx is x less than equal to 9. Because only for this part, your fx is positive. Yeah. Okay. And
How
your
do you get it algebraically though? It says determine the domain and range graphically and algebraically.
okay, graphically, how will you graphically you will draw the graph and you will check for what part this is graphically only. Yeah? This part you see that, yeah, your fx is positive, so you say that domain is this much. Now let's find the domain algebraically. Algebraically, what will you do? For a radical function, the domain is that whatever is inside the square root, it must be positive. So minus of x plus 9 should always be greater than equal to 0. If you add x both sides, so it will do minus x plus x gone, 0 plus x is x. So it says x is less than equal to 9. Same. So this is the domain of your f of domain of under root of.
Okay. Wait, that's the domain of under root?
Under root. Yeah. Under root of fx.
Shouldn't the whole equation be greater than or equal to 0?
Yeah, this the equation should be greater than equal to 0. But when you write domain, you only write in terms of x. You will always write a domain like this. X is greater than and less than equal to something. Uh, you will not write x 2x plus 3 is less than 4. This is not the way of writing domain. You will write like this.
I know that,
Yeah.
but shouldn't this be like that?
No, no. Oh, okay. No. I got this. For solving domain, the in part which is inside the radical function, that must be 0. That must be greater than equal to 0. This automatically is always greater than equal to 0. Your
Oh,
under root of under root of something, if there is no negative sign, it is always greater than equal to 0. So range of this will be always at least greater than 0. This whole radical function with under root. We have to
how would you find an
hmm.
invariant point for that?
Invariant point, we will have to just find where your y equals to
Algebraically.
algebraically. Okay. So algebraically, you need to find where this function is 0 or 1. So I'll put y equal to 1. Okay. You will get 1 minus 9 minus 8 minus x equals to minus 8. So x equals to 8. This is one invariant point. The other invariant point will be, as you said, where y equals to 0. So your x is 9. So these two are your invariant point. So if you, the graph will go like this. Between x equals to 9 and 8, this will be greater than, or I will draw like this. Don't mind my scale. It will go somewhat like this. The graph is very bad. You got, or should I draw it? Yeah. The graph will actually look somewhat like this. 9, 8. These two are your invariant points. Oh, any doubt?
No. Yeah, we can do question D.
Question
The
D.
same. The same, like graphically, algebraically, and invariant points for the domain and range.
Okay. So first, let's find domain. So, okay, so domain of this is x, all rational function. This, the internal part should be positive. So again, I will do 0.1x minus 5 should always be positive for the radical function too. For this because it is in under radical.
Wait, so the first one doesn't have a domain?
It has domain. For all real numbers it exists.
Okay.
Okay. From minus infinity to plus infinity. Okay. The main is finding the domain of the radical function.
Mhm.
Inside the radical, the whole function must be always positive. So I'll find the inequality in terms of x. Hmm. If I multiply the whole thing with a negative, it will become, sign will change, and it 0.1x is, if I subtract minus from both LHS and RHS, and x is, if I multiply the whole thing with 10, it becomes this. So this is the domain of the radical pair. Now let's check how this graph will look like.
Wait, I got something else. For this, I got x. That.
I think you didn't change the inequality when you multiplied the whole thing with the negative. The inequality will shift
Oh.
when you
It shifts when you multiply by a negative?
yeah, if you multiply the whole equation with negative, the inequality changes.
Okay. But
If
you keep the negative, right?
uh well, no, no, if I don't get your doubt. So this must be positive. If you multiply the whole equation with the negative, both side multiplied with negative, so the inequality changes. I will tell you why. 3 is greater than 2. This is true. Okay. If you multiply both sides with negative, -3 it will become, and -2. So which is bigger? -2 is bigger than.
Okay, okay. I understand.
Okay. So that's why this is next step. I multiply both the sides with negative. 0.1x plus 5 less than equal to 0 it becomes. So 0.1x is subtracting 5 on from both sides. Subtracting and addition doesn't change the sign.
Okay, I understand. What about range?
Okay, range. So what will be the range? You can directly tell. What is the range of this? For the linear function only, I'm telling. The linear function is minus negative to plus negative. Most of them, unless it is a constant or the domain has been restricted. In this domain has not been restricted, so it will go like, sorry, it won't work like that. Let me draw here. So -5 is here. Your graph will go like this. This is -50. So above -50 it is positive. This, so graphically also you can see your domain is correct. Your range of this is y ranges from minus negative infinity to plus infinity.
How is x negative 50?
X is okay, x negative 50. We calculated using this na. We found the domain.
Oh, okay.
We found using the function was positive. So from this onwards, the function becomes positive. That's how we got the domain also. Yeah. So the range of this will be from 0 greater than equal to 0. Why this y of radical function is greater than equal to 0? Or if you write like this, we used to write like this, from 0 to infinity. Whatever is in your textbook, whatever is followed, you can.
Wait, so for the linear function, it's this?
For the linear function, yeah. For a normal linear function, if it is not constant, either it can be a constant line in some cases, zero slope. This is like y equals to 5 or something like this. For it is the range is constant. If it has some slope, y equals to some mx plus c. Okay, some mx plus c, and m is not 0. And there is no boundation on x given in the question that x, it is not like x is between 6 or -6 to +2. It is not given. This x can freely exist. So always your y will be from a negative infinity to positive infinity. It can take all the real values.
What if x is limited?
X is limited, then we have to check. How we will check? I can. In that case, let's say this is a function y equals to 4x minus 6. A random linear function, and you say that x is only between -1 to +6. Just an example. So the slope is positive, your graph will go like this. So if the slope is positive, your minima of y will be at x minimum, and maxima of y will be at x maximum. So for if you put x equals to 5, your y will come 20 minus, this is 6. So actually,
Oh, so you just plug it into the equation?
yeah, you plug it into the equation and you get max and min
Okay,
in linear function.
let's do question 6.